What a pleasure to be with you. Thank you so much for the introduction. And it's a pleasure to participate in this webinar series. It's very active and very well received. You've heard about me. I have to say that this accreditation takes a community, and the community that's shared this, I'm honored to be with them. You see the last couple years of the semi-annual meeting, which has been conducted at ASTM. It will again occur in June, and you're all invited to this, either virtually or in person. I thank ASTM D35 for giving us an audience and certainly making us one of the biggest subcommittees inside the ASTM activity international. The Geosynthetic Institute is the mothership, and it has 5 institutes underneath it. The one that I'll talk to you about today is the accreditation, and it's the Geosynthetic Accreditation Institute. Please realize that we have a newsletter quarterly, and it's summarized inside that newsletter for our entire 40 years of history at the Institute. The Institute was incorporated in 1991. It got nonprofit status in Delaware, the state of Delaware, in 93, and it moved off the campus at Drexel University in 1999. The Institute's mission is to develop and transfer knowledge, assess and critique geosynthetics, and provide services to the member organization. And this it does in the form of accreditation for laboratory accreditation throughout the world. The GSI membership is broken down into 64 members, which represents these organizations. It's also governed by a board of directors and a board of advisors. I must tell you up front that GSI operates under ISO 17011. The Institute has a lot of very nice equipment. People see this equipment and automatically want us to go into testing for them. We cannot. We are not an outside test lab for hire. You can't play both sides of the street, so to speak. We are definitely the reference test lab for the GAI-LAP program, and solely that. We cannot do outside testing. What does geosynthetics in this day and age represent? I'm very proud to tell you that geosynthetics, the global market for this, has eclipsed $9 billion, 9 with a B. This is a compilation of information from Designing with Geosynthetics, GMA, and a bunch of other groups, particularly the ISO strategic plan. But it's interesting to note how large the industry has gotten, even with a few hiccups from economic factors and COVID. What this does not include is the $60 billion worldwide pipe. So you can add this to the total. If you consider plastic pipe as a geosynthetic, it certainly will dwarf everything else, and it is expanding quite rapidly as well. So geosynthetics, a definition, a manufactured polymeric material used in geotechnical engineering. There are 10 groups in them: textiles, grids, straps, cells, which are 3-dimensional, nets or spacers, which provide drainage in the plane, membranes, which provide barriers, GCLs, which are backups to those membranes, geomats and turf reinforcement materials, foams, both glass and styrene-based foams, composites when you marriage these materials together, and then appurtenances. All of which I just described to you have test methods and practices that are standardized. They're generic practices and test methods, and they all come under the purview of the accreditation program. The GAI Laboratory Accreditation Program is in its 29th year. The program started in 1995 at the request of the US EPA and other GSI members, most notably the big waste owners. We only accredit geosynthetic laboratories. In the introduction, a very nice introduction, you showed that I was a geotechnical engineer. Please realize that many other engineering materials have their own accreditation service. This one is solely for geosynthetics. We use ISO 17025 as our model for the accreditation. This is very important. You must familiarize yourself with this, and it's certainly the bedrock of what we're doing in the accreditation, and we share this with many other engineered materials. Audits are conducted on year 0, 5, 10, so on a 5-year cycle. Proficiency tests, however, are conducted every year. The goal of this is for everybody to get the same number for a test result, or a very similar number, to get that coefficient of variation down to 5. You must understand the hierarchy of the ISO standards. I said earlier, and I can define it as a pyramid. Please realize that government regulations, state regulations, all trump this hierarchy of ISO standards. The accreditation, as I told you earlier, the institute is 17011. That's how we operate. There's a product certification, an inspection certification, but the important one is the middle of the pyramid, which is the laboratory accreditation, which is 17025, which we'll go through in depth today. There's also a personal and a management system certification. The one at the bottom is of quite interest because this is the one that manufacturers use. 9,000 for the manufacturing process and 14,001 for the environmental side of things. So we'll see how these intertwine and integrate, but please realize the one that's the most pressing to us is the ISO 17025. You must remember that laboratories are not certified to ISO 17025. Accreditation indicates competence, and this is competence in the proper equipment, the proper protocol, and the proper training of employees. But there is no, we are not handing out certification or certifying test results. This is a misnomer that has to be put to rest straight away. Please ask the lab that does results for you or does testing for you. The labs are accredited for specific consensus test methods. In the laboratory accreditation program, these are only ASTM and ISO methods. One needs to be an educated consumer and asked for current evidence that the laboratory is accredited for this. This entire accreditation is in flux on a regular basis, and you must know that they're accredited for the time at which you're running that specific test. The value of accreditation certainly upgrade the credibility of the laboratory, provide a forum for communication, and we do this through semi-annual meetings at ASTM International. Another big item is this bullet point number 3, conflict resolution service. Many of the manufacturers join the program solely for this. GAI-LAP or GAI-LAP only acts as an arbiter. It reviews any conflicts, and it will actually do testing in our laboratory to see what result is indicative of the material. So this is a very big service and one that keeps GAI-LAP very active through the course of the year. The proficiency test program is conducted annually at the Institute, and this helps to determine uncertainty. And please realize that uncertainty is a requirement of 17025. So some labs will just conduct the PT program, the proficiency test program, to be compliant with 17025. It also encourages everybody to work to a correct or a right procedure. It has helped both ASTM and ISO refine their test methods so that the uncertainty is less with respect to time. The demographics of those who have participated with the laboratory accreditation program: 27 independent labs, 62 manufacturer QC labs, 5 centers, which are either research centers or government laboratories, and 11 laboratories have participated from the perspective of a PT program only. That amounts to 105 laboratories that are active, a total of 130, so 25 labs have either gone out of business or have assimilated elsewhere. But this amounts to over 600 audits that have been conducted in the last 29 years. There are 47, almost half of the laboratories are outside of the US, and they're in 23 countries throughout the world. The program covers 263 possible methods, those being ASTM or ISO. These are all consensus test methods, and it's growing ever stronger with both very active ASTM and ISO participation. This is what the world map looks like. You're well represented in Australasia with labs throughout the region. It's a good distribution. I should point you in the direction of a Geo-Americas paper that was written in 2016. It was a 20-year retrospective of the GAI-LAP program, and I think it's worthwhile if you're interested in becoming active in this program. As far as the application process is concerned, the laboratory will provide a contact information. They'll select the appropriate test from the list of 263. They'll complete an ISO 17025 checklist. I should point out to you that the most current revision of this standard is 2017. It's due for an update, and it'll probably update into the environmental section directly related with 14,001. You'll submit a quality manual, a standard operating procedures, and I was quite surprised to hear this. I learned recently from A2LA that standard operating procedures are not required to be laboratory specific any longer. So that means you can submit the actual test method as an SOP. I do not recommend this. I can't see how that's correct, but apparently that follows the rules of 17025. You need to submit an example laboratory report. And please realize reporting criteria is very different for a manufacturer quality control lab versus a third-party lab. A third-party lab has to comply with all ISO as well as ASTM reporting requirements that are written in the the test methods. This is not the case for manufacturer quality control labs. They can summarize this and actually write it down in a cut sheet or a spec sheet, which is very much abbreviated from this. And this is a difference in the reporting criteria. Document control list is required. An equipment inventory with a calibration schedule is required. Corrective action summary, an audit summary, both internal and external. And then this internal reference material, which is used for calculating uncertainty, and that list. There's also a personnel and training summary, which is required as well. So the submittal for the application is quite involved, and sometimes it's an iterative process to get it all in so that you can schedule an on-site audit. The audit, again, is year 1, 2, 5, and 10. There are no more virtual audits. We had virtual audits through the course of COVID for about 2 years. I don't think this was optimal. There's nothing like being in person. So schedule will be sent to the laboratories in advance, and the objectives identified, and it's typically threefold, the objectives. The objectives usually work out to wanting to obtain accreditation, continuing accreditation, or just a cursory visit to see how you're doing and not a formal audit. So there are the three options to identify objectives. We then go through a document review on site. You have to agree on the proposed assessor. You can turn down the assessor if you've had a bad experience in the past or want a different assessor. That's certainly at your purview. The assessor then conducts the audit, and they're typically demonstration tests run at the audit. This is not a full-blown proficiency test, but this is so that you can demonstrate, and everybody communicates well through numbers, so you can see if you're in the right ballpark or in the right region with the values from the test method. Report deficiencies with an audit report, and this subsequently is reviewed by the group. I said in the beginning that you need to be very familiar with 17025. And I'm going to go over 3 sections, the first of which are the resource requirement. This is general, personal, goes through the facilities and the environmental conditions, then looks at the equipment, the traceability, and then, the providing products and services. So these are the resource requirements for 17025. The first thing that I should tell you is training of their personnel. You must keep up to date with the ASTM as well as the ISO methods in regard to training of the personnel. This is critically important. They must be trained regularly, and they have to be updated. In addition to that, all of the methods that you're accredited for have to have trained personnel to do that, and they have to show proficiency at that particular training. I should not underestimate safety. This is a requirement in the training program. Every test method, safety precautions, and ways that you could get hurt should be identified. There are training tools, experiences, first aid, regulations, insurance, health, and protective gear that you can wear throughout this. Your laboratory should be versed in it, and any auditor will ask you if you've had a health and safety or workplace injury and want to note it in your particular case. The environmental condition, The environmental conditions must be controlled, monitored, and recorded. This is typically in the form of temperature, humidity, and altitude. Temperature is the most critical of them, and that is typically maintained at 22 plus or minus 1 degrees C, depending on the test method. The environment has to be suitable for the test and should not adversely affect the validity of the results. The environment is checked. I have to be forthright with you. There are cases where altitude and humidity do not affect olefin plastics, and some labs just control temperature. As far as traceability is concerned of the equipment, the traceability is typically traced back to a National Institute of Standards. This is as traceability goes up, the uncertainty goes down. You can spend a lot of time, money, and effort with this, and there has to be a point of no return with this. I have to tell you, many labs do their own calibration and verification. This is with traceable equipment. It's permittable under the GAI-LAP program. Some other accreditations do not see fit for this. This is a different or a departure for the GAI-LAP than some other accreditation programs. You have to check that out with your auditor when you're in your application process. The next one is the process requirements, and this is broken down into 11 different sections. Review, request, tender, and contracts. You can imagine this is very different from a manufacturer quality control lab versus a third-party laboratory. The manufacturing quality control only works for production, where the third-party lab has outside contracts, so it's very different. Validation, sampling, handling, we'll talk about. The record, you have to know the difference between a record and a document. A document is living. A record is fixed to time and place. So a document can see revisions, a record cannot. So this has to be made sure of. We'll speak a lot about uncertainty coming up, the validity of the results. You might want to check with an internal reference material before and after a series of runs to make sure that your results are valid. Reporting of results, we talked a little bit about that, but there's more with inside the test methods themselves. As far as complaints, you can receive these in many different ways. You can receive them from outside from a customer survey, or internally from a technician or a audit. Non-conforming work, mistakes are made. How you bounce back from these mistakes is probably more critical than the mistake itself. But so you don't repeat the mistake, and that you have a process in place to correct. Controlling the data and managing the data is often done off of a laboratory management system, and that should be discussed as well. Preparing specimens, test specimens from the roll good is extremely important. You should get a statistical average across the material. Many test methods are silent in this regard, and then in that case, you should use the general practice outlined by either ASTM or ISO. A lot of dyes are used both in membrane and textile testing. Please realize the important is that the specimen that's produced from the dye, I see a lot of people measuring the dye. This is not the critical factor. The critical factor is what is produced. The specimen produced has to conform to the requirements in the test method. As far as handling is concerned, there's a bunch of handling requirements. The first is of the laboratory. The laboratory typically has limited access. All the computers are typically password protected. The software within the computers is typically locked, so it cannot be changed, any calculation. Often the LIMS system does not have internet connection. No thumb drives are allowed because of viruses or hacking. It's usually uploaded to the cloud on a regular basis, and that's usually at day's end. There's also inspections. This is incoming inspection of the material in process, let's say when it's in a continuous rate of extension machine, and then there's a final signature. Please realize that most labs are conducting risk analysis, and this is to alleviate problems with inside the laboratory. Uncertainty is a requirement through 17025. Uncertainty, they do not tell you how to calculate it. It can be calculated in many different ways, through precision and biased statements, through actual collection of data. My favorite way is the last here. Uncertainty is the square root of the sum of the squares of repeatability and reproducibility. Repeatability is obtained in one laboratory. Reproducibility is obtained in a group of laboratories, and that's what you get with the GAI-LAP PT program. So you get your reproducibility in a PT program like that. The third section that I wanted to talk to you about is the management system requirements with inside 17025. And a big one is clause 8.1. And there's an option A, which outlines 17025, and this is for third-party laboratories, and an option B for manufacturer quality control. A third-party laboratory cannot select option B. This is for manufacturers only. Please realize that 9001 goes hand in glove with 17025. The emphasis is not on the laboratory, but that's what you're auditing. But please recognize this with inside clause 8.1. You'll go through a management system documentation, control of records. And please realize in this age of hacking, that control of records is becoming much more of a challenge. We've seen several of our laboratories hacked. It's quite unpleasant, and you really need systems in place with your IT department to ward off these risks. You'll identify risks and opportunities, identify areas of improvement. There'll be corrective actions, as well as internal audits and management review. Corrective action is usually the first item that an auditor asks for when they go in for an audit. They want to see that the quality system is alive and well, and that entries are being made to the corrective action program from all different avenues. So this is critically important. You're looking for continuous improvement and certainly a reduction in risks and problems as you participate longer and longer in these accreditation programs. And I think we see that across the board in the 29 years that we've been conducting the program. As far as improved laboratory quality, you have inputs for the management review and then subsequently receive outputs from it. This should be active. It should show benefit. We are always quite suspect when we don't see benefit from a lot of effort. Some people choose not to go forward with it because they're not seeing benefit. You should definitely get a return from the laboratory accreditation, and it should be notable and very pronounced. It's a proper way to do business, and certainly has worked for many. As far as the closing meeting is concerned, the auditor should distribute copies of all reports. Please realize this report should not be handed over on a flash drive, which could corrupt an internal system. It's typically emailed and blanketed emailed to everybody. Identify all personnel who attend the closing meeting. Initial any changes to the report for the report of deficiencies. Um, you'll review the assessor's report with an audience. Everybody will sign off on this, and then certainly you'd identify timely response. Usually a couple months are given unless equipment needs to be purchased. The PT program I've talked about, or at least mentioned. Please realize last year we conducted over 5,000 PT tests. There were first-time outliers, 43 of them, which were greater than 2 standard deviation plus or minus from the database mean. This occurred at 27 of the 105 laboratories. All of these outliers were or anomalies were identified, and cars were submitted. These attribute to learnings. We pass these learnings on at the semi-annual meeting, and certainly as a group, we've learned from them. The proficiency samples are given with the generosity of the geosynthetic community. We could not operate without their generosity, and thank them very much. We're loaded up for samples for next year, and it's really a privilege to work with this community. The calendar of GAI-LAP events, usually in January. We have a meeting, proficiency samples are sent out, and the proficiency samples are due April 15th. We calculate the database, in the end of April, beginning of May, and then subsequently the accreditation runs from June 30 to June 30. The directory is published every December, and the cycle continues. It's a very active year, and at the Institute, almost 40% of our business is just the laboratory accreditation program. We have joined forces with A2LA. This is a very well-established 45-year-old program. They not only have over 100 laboratories, they have 4,000 laboratories. They're headquartered in Frederick, Maryland, with about 80 employees. And the reason we joined forces with them is that the international picture. Please realize we acknowledge that the GAI-LAP program is small. It's very targeted at geosynthetic only. Some of the laboratories, though, wish for a much broader reach, and this incorporates ILAC. ILAC has an agreement with A2LA, and therefore we joined forces with that. There are now A2LA auditors who have geosynthetic prowess. There are about 6 to 10 of them now. You can request these auditors and obtain A2LA, GAI-LAP, and ILAC accreditation all in one fell swoop. So I've talked quite a bit about accreditation, and I'm a numbers person. So let's take a look first at specifications. and how these accreditations play out in both textile and geomembrane specifications. And then let's look at 3 case histories and how GAI-LAP data marries into these items. So the first table I show you is for geotextiles, and these tests that I called out, the 10 test methods, are typically referenced with inside of AASHTO M288, permittivity, xenon arc weathering, trap tear, wide width tensile, grab tensile, AOS, thickness, mass per unit area, and CBR. Here you see the values for RS, which were obtained at GSI, then the reproducibility, which was obtained through the GAI-LAP, and then certainly the uncertainty. You might be saying these numbers look a little high. They're the 29-year cumulative numbers. They get crisper over time, but this is an honest portrayal of what these numbers look like over the past 29 years. We have to admit that we've educated a lot of people in here. Some of the data has been poor initially and gotten better, but this is what the uncertainties look like. They're a far cry from single digits, but improving. The second group of data looks cleaner. This is for geomembranes, and it happens to be the membrane characteristics for GM13, which is our most reviewed and most referenced specification. We have thickness, density, tear, yield strength, tensile, puncture, stress crack, carbon black content, carbon black dispersion, OIT, both high pressure and standard, oven aging, and UV fluorescent. These numbers look tighter than the textiles, and it should be. The membranes are more repeatable and reproducible in their test methods, but it gives you a general flavor of this. We see the index methods are quite tight. The survivability mechanical properties are good. The endurance properties, it gets a little shaky when you get to the endurance properties. But this gives you the lay of the land from perspective of both geotextiles and also geomembranes. Now let's take a look at the 3 case histories. The first of which is a high strength geogrid, which is placed over columns. Here you see the Airbus terminal, the extension of it. And I submit to you that that high strength geogrid needs to have its tensile strength and its tensile strength examined quite readily. This is what that geogrid looks like underneath that pier. Certainly the geogrid is acting as reinforcement and doing so quite well. If you go into designs, critical, this one from McGuire I like very much, and it will form a catenary over top of the material, but you're looking for a tensile strength. That test method, 6637, you're looking at stress versus strain. You're very interested in the preload, the specimen preparation, the strain measurement, the grips, the strain at 1, 2, 5, 7% modulus, and the ultimate tensile strength and strain of the material. So this is what you're looking for that material. And how do we look for the GAI-LAP program? For ASTM 6637, the results for strength for this particular material, an average of about 42 kilonewtons per meter. The standard deviation was 4, with a coefficient of variation of 10. So I think we did quite well. This was tested in 2020, and I'm quite proud of this set of data. The data gets a little squirrely when you go to strain. The average was 19%, standard deviation of 3, with a coefficient variation of 16. I would like both of these coefficient of variations to be under or single digits, but it's how it worked out for this 40 kilonewton per meter material in this particular case history. The next case history that I'd like to talk to you about is for a geocomposite. This geocomposite is a drainage geocomposite made up of a core and an outer geotextile. It's used between the back slope and the reinforcing zone of a retaining wall. Here you see the water emerging from that back slope. You're going to cover it with this geocomposite drainage material. And this is from Bob Kerner's Designing with Geosynthetics. You see the retaining wall up there, and you're looking for a transmissivity value or a flow rate value at a normal pressure. And we're targeting around, pardon me, it's around 2000 PSF, and looking for a flow rate. The flow rate, it comes from a transmissivity unit. You see it here in cross section and photo. It's ASTM 4716. The relationship between flow and transmissivity is shown here, and the test results at a gradient of 1, because this was a vertical installation. The pressure was about 96 kPa. The transmissivity was 2 times 10 to the minus 3 meters squared per second. Standard deviation was almost an order of magnitude less, and the C coefficient of variation was 22. We had over 25 laboratories participate in this proficiency test program. Again, the coefficient of variation was a little bit larger, but these are flow tests rather than tensile tests, and the variation has shown itself to be larger with respect to time. The last one is direct shear, and you see, as a geotechnical engineer, I went after the major 3 properties for an engineer: tension, transmission, and direct shear. This is a large-scale direct shear unit, 300 millimeter by 300 millimeter. The case history is a landfill cover. In this particular case, it's a you see the slope before and after. We knew we had problems because there were gathering of the material at the base of the slope. So the cross section looked like a PVC geomembrane, a geocomposite made up of 2 geotextiles on the outside of a geonet, and then about a half a meter of soil over top of that. Here you see the gathering of the material at the toe, right in the drainage swale. Here you see it a little bit better. Where did all that material come from? It came from upslope. There was actually a breach. You saw a crack open, and then a ripping of the material up top. The failure was between the geotextile and the geomembrane. And from a very elementary review of this computer program, you can see when the friction angle is 19, the factor of safety is 1.14. When it's dropped down to 16, it goes below unity. So this is the design for the PVC against needle punch non-woven in a saturated condition, run with ASTM 5321. Normal pressure of about 2 psi or about 14 kPa. The friction angle was 18 with a standard deviation of 1. I'm very proud of this sequence of data. 15 labs participated, and they did yeoman's work in this regard. And it really shows the power of running this, and certainly these results can be used in design. So, summary and conclusion, I think geosynthetics work very well. I've seen them do wondrous things that we cannot use or do with natural soils. For some geosynthetics, there are no natural equivalents. Unfortunately, it's tricky. It's tricky to install, and you have to do it right the first time. There are tremendous benefits for a system approach, a quality system approach, which leads to very good performance. And this quality system approach uses a good design, quality materials, and that one is highlighted, accredited testing, best available installation, quality assurance, proof testing before commissioning the facility, and then careful operation and maintenance. As some observations about laboratory accreditation to conclude, this is obvious, but you need to follow the test method. This is easily said by an English speaker. I feel terrible for folks that don't have English as their mother tongue. But there's some very subtle points inside the test methods which are overlooked or missed. You have to follow the methods to a T. Not all tests are created equal. This is haunting. For instance, we have two test methods for the tensile properties of geomembranes, ASTM D638 and 6693. They give totally different results. The reason being is they're different shaped specimens. One uses an extensometer. One uses crosshead movement with assumed gauge lengths for yield and break. So you get very different responses, and further yet, you get a very different response from ISO 572. So not all tests are created equal. They might be similar, but the correlation between them is very difficult, particularly when you're running them at different speeds and under different conditions. You need an approved plan for success and to succeed. And to set out that plan through a laboratory accreditation program, I think is of great value. And certainly a quality system approach is highly recommended. I think all of us are better when we have a peer review, myself included. I think this is of great value. Different eyes on the same procedure always bring forth better things, and this is very important. We've learned over and over that the grip should not initiate a failure, and that rupture should occur within the gauge length. These two rules married together will save you a lot of time and effort in mechanical testing. Laboratory testing is not, and work is not for the faint of heart. It takes a special person to do it and do it well. There's a lot of patience, and it's not always obtained on the first try. It's an iterative process, and some of it can be quite time-consuming and painful. It has been an honor working with the group for the laboratory accreditation program for the last 20 years. I thank you so much for this, and it's really been a big part of my life, and thanks for hearing me out this evening. If you have questions, I certainly will take them now. You can visit me at the Institute's website or go through the GMA tech line if you're interested in that. But thank you so much for having me.
Thanks a lot, Dr. Kerner. That's a really, really interesting presentation. If you have any questions, guys, please do post it on the Q&A. We have one question on the Q&A at the moment, and I have a few, and I think Jonathan also has. Let's read it out. What's the difference with being an ISO 17025 accredited laboratory with the likes of A2LA or NETA compares to GAI-LAP accreditations?
It's the recognition. I think let's face it, the GAI-LAP program is small. It does not have the outreach of ILAC or the memo of understanding for that. We don't want to portray something we're not. This is a small niche market, and it does not have the reach of one of those big programs that might have a requirement through a government or a national lab.
George, my question was more philosophical one, I guess, is how much is a lab accreditation tied to the lab or to the actual person doing the test?
Oh, Jonathan, you nice to see you. It at the end of the day, it all comes down to people. It's somebody who cares, and to harness this is not easy. Certainly, you have to have the right people with the right mentality. It has to have the right leadership. You try to capture this, but we're all human. Sometimes it breaks down, but very well put and very, very honestly taken. You can have the greatest machines in the world, but if they're not the right people there operating it, you still won't get the right result.
Coming to people, Dr. Kerner. So are there any requirements within the GAI-LAP in terms of with experienced technician? Are there any requirements that mention that there are certain experience required to run a certain test?
Yes, there are. There are technician accreditations, and they're set up in different industries with certification programs for the technicians. We've dabbled with that. We have trained people at the Institute, but it's much better to train a person on their equipment on site. So that has also been done, but it has never been formalized. But thank you for asking. That is an option.
If I could just finish off by saying, George, thanks very much again for your time today and for letting us know about this really important part of the QA process. For us as designers, it's really important to understand how these tests work and how labs verify that they can do them, and also gives us a bit more certainty when we're using those numbers that the person who's done the test cares about them, I guess. And just like to say, the first call for GeoAsia 8 went out today for abstracts. GeoAsia 8 will be in June in 2025 in Brisbane. Looking forward to a lively event that essentially covers the whole Asian region within the IGS. So yeah, keep an eye out for that and start thinking about good abstracts to submit.
Thanks, Jonathan, for closing it. If we have no more question, or if you wanted to contact Dr. Kerner directly, please feel free to use the link shown on screen. So if there are no more further question, I would like to thank you, Dr. Kerner, for your time in the evening, for giving such a great presentation and also all the participants are participating the webinar. Right, see you all, and have a good evening, good day,
Cheers.
and see you in the next webinar. So guys, bye.
Bye now.